All right, so this talk is how do you set boundaries, AWS permission boundaries in large cloud environments by Kushagra Sharma, right here. Before we get started, I must announce one of our sponsors, that is NetSpy. NetSpy is a global leader of offensive security. We offer a complete range of services, including pen testing, attack surface management, and breach attack simulation. Our cutting edge tech and expert team help organizations identify, prioritize, and fix security vulnerabilities. Scan the QR code in the sponsor area to be entered to win a JBL Clip 4 speaker. Thank you all. Okay, good. Thank you, Kushagra.
Thank you. So the topic for today is how do you set boundaries, that is AWS permission boundaries. And before I start, a quick introduction about myself. I'm Kushagra Sharma. I'm a senior platform security engineer at Booking.com. So the agenda for today would be the challenges with IAM management, especially for organizations with a greater cloud footprint. Then we'll talk about permission boundaries in a nutshell. Trust me, I wouldn't read the AWS documentation here. Then we'll move into how at Booking.com we tackle the permission boundary with a flavored approach that might be very different from the generic use case. And then we'll talk about the implementation that's building dynamic boundaries with Terraform. And I'm sure you might have a question towards the end that does it scale? So I have some homework done to answer that question beforehand. And towards the end, we'll also talk a bit about developer experience and how permission boundaries go hand in hand together. So let's get started. What are the challenges with IAM management, especially in large cloud environments? One, myriad compliance requirement. Every other day, you get new requirements, which are very difficult to implement, trust me. Second is evaluating effective permissions for developers gets really tricky. Like they are really not sure what's allowed, what's not allowed, because you have SCPs, permission boundary, different controls, so they really are lost at some point. Then third is difficult to keep up with new AWS services. So every other week you have new services, new feature releases, new IAM namespaces, so how do you keep up with the velocity by which AWS is releasing services, right? And then what happens towards the end is that security teams, they end up doing the operational work for project teams, which is not so nice. And towards all of this, towards the end, you hear that, okay, security is the one creating friction, which we don't want to hear, but trust me, it happens. So what's permission boundary in a nutshell? So on the left, you see there's a single boundary that's defined by the security team, which is saying allow IAM asterisks, but deny IAM create user, because we really don't want IAM users in our environment. We want IAM roles. Then the developer, he comes up with an IAM policy that says IAM create asterisks. So he's under the impression he might be able to create a role, a user as well. But the effective permission is that it allows IAM create asterisks, but it still denies IAM create user. So whatever you define in the boundary, no matter whatever identity-based policy is being attached to the role, the effective boundaries are always governed by the permission boundary, which is quite handy for security teams. Now you might be wondering, in every sentence I speak, I'm talking about permission boundary. So if I don't remember your name, you know the reason. Okay, so is it possible to build a one-size-fits-all permission boundary, which can tackle account-level exceptions, allowing only vetted service for service deployments, considering not every environment is the same? So how can one boundary suffice the need for security teams? Then you have regulatory requirements to add to it. And towards the end, you also have growing number of AWS accounts. So is it possible or not? But yeah, we'll come to that later during the talk. So at Booking.com, what we came up with is a flavored approach to permission boundary. So what we came up with, there's one dynamic boundary with global sane defaults defined by the security teams. Then we are allowing exceptions to the boundary on a per account exception basis. And then we are also enabling developers to contribute to this boundary. Of course, given they have the certain approvals and you need the approvals to deploy it as well. And for environments falling under a specific regulatory scope, we have a new flavor to the boundary. So think about you have a PCI environment where the requirements are really very different from your generic production environment. So far, it sounds super easy, right? You define the maximum permission that any IAM entity in your environment can get. You enforce that centrally using SCP, perhaps. You centrally manage and deploy this boundary to all your production accounts or all your AWS accounts. And then you think you have demystified the IAM universe. At least that's what we thought. So let's find out. Now it's the build time. So what we started with is to define a global boilerplate in the boundary itself. And as like very basic example, one of them was to define a global deny list for actions, like actions that are a no-go in your environments. So for example, you don't want certain networking actions like creating internet gateways, someone attaching them to your EC2s or whatnot. You don't want them to create IAM users. So based on your environment and your use cases, you define a certain global list of no-go actions. That's one. Second is region restrictions. So often with regulatory requirements, you have, okay, you need to only deploy in EU, for example, or you only need to deploy outside EU. So how do you tackle that? So we added another condition just to allow certain region restrictions. And then towards the end, we added a service allow list, which is basically telling only the services that are vetted by the security teams are allowed as part of the boundary, because you cannot allow any services as soon as they are released. So this was the very basic boilerplate, but it doesn't cater to all the needs. So how would you handle account level exceptions now? Because you have the global boilerplate, but how do you handle it on a per account basis or a per OU basis, for example? So what we did is, using Terraform, it came in very handy. We defined a hash map. And what you see on the screen is a very generic example. So we said, OK, if you want additional regions, we have it in the hash map. If you want additional IAM actions, we have it there. If you want additional networking actions, we have it there. We were also enforcing certain base images or golden images, as you say it. But for example, you need to deploy a vendor tooling. You need an AMI from the marketplace. So we have a placeholder saying allowed AMI owner IDs, where you can specify from which specific account you can deploy an AMI. And this all happens on a per account level. So all the ticks you see, onboard additional service, tick. New region deployments, tick. Add new trusted source for another controls, tick. So now you might wonder, how does that end up on the specific AWS account, right? So that's the next part, which is the build time. How did the boundaries shape up eventually? So here what you see is there's an input boundary list which says for account number 0, 1, 2, 3, whatever, it's a networking AWS account. And here we are allowing RAM asterisk and shield, so two AWS services that were not defined, that were not allowed in general boilerplate. Then we are allowing them to use additional regions because it's the networking team's account. Then we are allowing them to deploy from marketplace with some specific vendor accounts that are safe listed in the list there. Then below you see there's another account number, which is a project XYZ account, where we are saying, let them use AWS data sync service. So now what happens is, eventually, for a specific networking account, they're getting these additional permission just for their permission boundary in their account. For the other project account, they're getting just those permissions for their account. And based on your deployment logic, you can also target this to a specific OU. So it's actually, if you think about it, every account can have a different permission boundary with the global same defaults that we defined earlier. Win-win, right? And how do we achieve it? So this is an example using Terraform. So Terraform has a very nice, beautiful thing called dynamic statements. So what we were doing is, based on that input list, if there's an input for a specific account, you materialize that dynamic statement into the boundary. So the first one is basically taking care of additional allowed regions. The second one is basically enforcing AMIs. If you don't have the input list, the basic global boilerplate kicks in. So this way, you are really able to tackle account-level exceptions, account-level deployments, and you can also cater this to specific region deployments. Then coming to the last step, how do you enforce this? So what's nice is AWS has a specific condition key, which is IAM permission boundary. So you can really enforce your boundary using an SCP, where you say, hey, don't allow anyone to create a role or an IAM user unless he has this boundary attached. So what happens is you deploy this boundary as part of the security baseline in every account. You enforce using the SCP. Then all the IAM entities in your environment has this permission boundary, else they cannot proceed. So this way, you also get full 100% coverage into your permission boundary roles. Now, the question was it possible to create a one-size-fits-all permission boundary? So it seems like we have answered the question. We tackled AWS account-level exceptions. We are only allowing AWS vetted service deployments based on the global allow list. We have a flavored approach in case you want to create a new flavor of the boundary for very specific AWS environments. And also regulatory requirements can be adhered to. At the same time, you're also reducing the friction because developers, they can self-contribute to the permission boundary using the self-deployment model. You're reducing the operational overhead for IAM or security teams to actually ensure that the permissions are right following the least privilege model. And with IC baseline deployment, it gets really easy. So in the example that I presented, it's using Terraform, but it could be any other deployment workflow. But with infrastructure as code, it really gets easy to get this into action. Now, the million-dollar question, does it scale? So just to give you an idea, it's working so far for almost more than 1,700 AWS accounts in one of our environments, which is a huge number, if you might ask. We have it enforced. All IAM entities have the permission boundary based on the use case. You have regulatory requirements. You have a different flavored boundary that's enforced. So all roles have the permission boundary. So we really have a guardrail enforced end to end. Then we again thought we have demystified the IAM universe. But then we saw something in our CI job logs which said we cannot update the permission boundary because it's exceeding the policy size of 6,144 characters. And then we thought, okay, maybe we can attach more than one boundary to an IAM role, just like IAM entity, IAM policies, SOPs, but that doesn't work. So as per AWS documentation, you can only have one boundary attached to an IAM entity, and it cannot exceed the size of 6,144 characters. But as others spoke about as well, there are ways to optimize the size of the boundary. So you might do some compression, remove some certain IAM namespaces, put asterisks to make it a bit more less in size. But at the same time, you might ask, we also have SCPs, so why are we putting all the controls in the permission boundary? The answer being you need to find a balance between SCPs and permission boundary. So all the actions that are very sane, where you don't anticipate any exceptions, they should go to your SCP, enforce them via SCPs. Be it like any networking actions or any IAM-related actions, maybe protecting your tooling role, baseline roles, they should go into the SCP because there wouldn't be any account-level exceptions or OU-level exceptions, for instance. But for controls, where you need control or more granular control, then you put them into the permission boundary itself. So that's where you need to maintain a balance. And I hope AWS is listening to some of our pain points here. So yeah. So that's the answer for does it scale. Now, this is the towards last, probably the slide of this presentation. It's the developer experience. So now, as I mentioned, it's a self-service model. Developers are deploying their IAM roles. They have the permission boundary enforced. So how does this go with permission boundaries? So the first thing is we have the AWS native policy simulator support. So in case they are running a simulation, they can clearly see that this action is denied by the permission boundary. So it's not a gray area that people don't know what's happening behind the scenes. That's a really good thing. The second thing is that you also see implicit and explicit denial messages for troubleshooting. So if you have an access denied, you really see the reason why it's not happening. So what we at Booking.com, we really wanted to make the developer experience seamless. And with the permission boundary approach, it's going so far so well. At the same time, using a central security teams are able to enforce controls at the organization level. And trust me, when it comes to cloud audits, if you say your controls are in SCPs, permission boundary, it gets easier. But if you point to external tooling, some internal tooling that you built, that increases the audit scope. So for us, it was really important to also get some more tough audits done. And on that note, I would say thank you, and I'm open to questions.
Any questions in the room? All right, I think I have some. Questions in the Slack. You guys can always Slack the questions too if you don't want to use the microphone like a fool. All right, like me. Let's see. How often are the engineers asking for changes to the permissions boundaries? Like how frequent is the changing that's going on to the actual boundaries themselves that you find?
That's a good question. So our deployment model, we release the baseline, and the permission boundary is part of the baseline. And this is happening every week. And as I mentioned during my talk, we have a self-service model. So developers, if they have the necessary approval from the risk teams, they can go create a PR, update the permission boundary, trigger a deployment, and then it's up to the security teams to approve that change. So it's an ongoing effort, and every week we have a major release to the boundary itself.
Any questions? I have more. All right. I've heard that there can be impacts to the way the AWS console operates when you have permission boundaries in place. Have you guys run into any of that, where certain functionality starts breaking that you just normal console usage?
Right, we had some edge cases with permission boundary not going that well if you create a custom service link role, for example, and in the troubleshooting, it wasn't really clear where the issue is. But yeah, that's something we face from time to time, but it's not a common use case. And in terms of the interactive services, what we have is we have another flavor of the permission boundary, which enables developers to interact with services that require interactive access, which could be Athena, for example. Because at Booking.com, we have infrastructure as code enforced everywhere, but there might be a reason to access the console to do certain actions.
All right, I'm out of questions. Anyone? All right, we can. Thank you, Kushagra. Thank you so much. You know where to find them.